Indonesia's irresponsible fishing activities and increasing pollution from factories and the like has led to the destruction of coral reefs. In Indonesia, gas emissions due to agriculture and industrial processes give rise to ocean temperature, causing coral bleaching, a phenomenon that caused the death of thousands of square kilometers of coral reefs. In fact, 30% of world's coral reefs perished in the last 15 years due to climate change and other human activities. So, our team, the Fish Keepers, have come up with Fish Hive, a solution that focuses on the SDG 14 goal, the conservation of marine resources for sustainable development. Fish Hive mimics a beehive, metaphoric to these reefs being home to marine life, like a beehive is to bees. AI has further supported our idea by saying that a beehive design shape offers some advantages for artificial reefs, by maximizing surface area, promoting water flow, and creating a complex habitat structure.
By focusing on these specific goals, we came up with several initial designs. However, there are several problems that encountered the shape of these initial designs, that is the structural integrity or strength of the structure. We decided to provide walls of protection for further shelter and for lessening the impact of wave pressure. With a higher surface area for cover, the force will be spread out, limiting a pressure receive and reducing the risk of the artificial reef model breaking. This is based on a specific scientific formula for pressure. Pressure equals to force divided by area. After several tries, we ended up with these features for our final design. We decided to implement by requires to take advantage of a low, safe electric current. This electrolysis method allows for calcification and mineral accretion. So minerals like calcium carbonate form solid limestone around the metal electrodes. Calcium carbonate then attracts coral polyps, which are components of a coral. Biotic method is also good for coral farming as it promotes coral growth rate by 4 times and helps injured corals by its ability to heal coral cell membranes. These wires are arranged in a layer pattern to create ground for friction for wave breaking.
It is built to break ocean waves while remaining friendly to the ecosystem and its inhabitants, as well as protecting coastlines from coastal flooding and other potential damages from the sea. We also decided to use geopolymer concrete as the base of our reef, as not only is it durable and has a rough surface for friction, but it also has a lower carbon footprint compared to normal concrete, which is used in a lot of artificial reefs. This conveniently aligns our design with SDG 13, climate action, as we try our best to reduce the carbon footprint of our design. Our design is also fitted with tunnels, which fish prefer, and holes, which crustaceans prefer, to give marine creatures a safe shelter to thrive, promoting biodiversity. Eventually, we came up with our final design, the Fish Hive. We tested our design in a fluid simulation and noticed how the water particles slow down after encountering the reef. However, we noticed that there is a deflection in the water wave because the height of the water that we used in the simulation is too shallow, only 1.2 meters. Meanwhile, we're going to implement our design on the seabed, which is around 30 meters deep in the ocean.
Our design was created so that it can be used by local communities, marine scientists, government, and most importantly, marine life. While the process of making the reef into a healthy and active artificial reef may take some time, this process is effectively sped up by the integration of biorock to our design, providing it with an advantage over other artificial reefs. In the future, we hope that Fish Hive can be a biodiverse habitat for thousands of species of marine creatures and become a great place for coral conservation and farming.